Okay, lesson 2 here is applications in finance. So we're going to do some of the examples here. We won't do all of them. So basically, investing money, there's two types of interest that you get paid or that you have to pay. Simple interest is where they just calculate interest once a year, and they only calculate it on the amount that you had in there originally. Then you have compound interest, where you calculate interest on top of interest, so the interest compounds. So we'll quickly go through the section on simple interest. So if you invest $500, which earns an interest rate of 6% per year, how much interest would you earn in a year? Well, in a year we would just take our $500. Whoops. We would take our $500. We're earning 6% interest, so we find 6% of 500 and we get 30. In half a year, well, we would get half of that, so we would get 15. And in 1 month, well, there's 12 months in a year, so we would take our $30 and divide it by 12, and we would get $2.50. There is a formula that's they use for simple interest, which is P, which is the principal or the initial amount, times the interest rate, so your percent as a decimal, times time, and this gives you the amount of interest paid. This is not on your formula sheet. Also, it's very unlikely they're going to ask you a question about simple interest on your diploma exam. Most everything is calculated in compound interest, so that's what we're going to focus on. So the biggest difference between compound interest and simple interest is that compound interest, you pay interest on top of interest. Simple interest is always calculated on the initial amount, so compound interest goes up much more quickly. Okay, we're going to skip the investigations and we're going to go to the examples here. So here's a formula for compound interest. So here we have A, which represents the final amount. P is the initial principal. 1 plus I, which is your interest rate per compounding period. And N, which is the number of compounding periods. Now this formula is not on your formula sheet, but it's very similar to this one, which is on your formula sheet. The reason we go 1 plus I is because we're now looking for our final amount. So we keep what we have, plus we add a certain percentage. So getting 6% interest, we're really getting 106% of what we had before. This is the biggest mistake people make. Note that I does not always represent the annual interest rate, N does not always represent the number of years. So we need to often change the interest rate and the number of compounding period based on the information we're given. So we're going to go down to example 3 here. So $7,000 is invested in a 6-year GIC compounded quarterly at a rate of 5% per annum. Determine the value of the investment at the end of the term. So A is what we're looking for. We want to know the value of the investment. P is the principal or the amount invested, so that's $7,000. I, so remember I is the interest rate per compounding period. So we have an annual percent of 0.05, 5%, but it is compounded quarterly. So that is 4 times a year. So that means in each compounding period, the interest rate is 0.0125. So since it's compounded quarterly, we need to divide the interest rate by 4. The N, how many times is this interest rate compounded? Well, it's in there for 6 years, and it's compounded 4 times a year, so that gives us an N of 24. So now we're ready to substitute in. So 7,000 times 1.0125 to the 24. We substitute that in now, and we get 9,431.46. Next example. Christine invested $2,500 for 4 years, compounded semi-annually, and received $843.26. What was the annual rate of interest? Okay, so now we are solving for I. So we start with our final amount. Well, She invested $2,500, plus she received $843.26 in interest. So the final amount there is $3,343.26. P is the principal, well, that's the initial amount, so the $2,500. And the number of compounding periods, well, it's in there for 4 years. It's compounded semi-annually, so that's twice a year, giving me an N of 8. So when I go to this equation here, 3,043.26 equals 2,500 times 1 plus I to the 8. So to solve this, I'm first going to divide by 2,500. So I have 3,343.26 over 2,500 equals 1 plus I to the 8. You can take the 8th root of this, of both sides, which is the same as putting something to the power of 1 over 8, so either way works. And you get 1.037 equals 1 plus I. Move up here. Okay, so this tells me I is 0.037%, or sorry, 0.037 or 3.7%. But it does ask for the annual rate of interest. This right now is the semi-annual rate of interest. So the annual rate, we're now going to have to times this by 2. So we have an annual rate of interest of 7.4. So when we did the last equation here, we took our annual rate and we divided it by the number of times we compound it. Here, when we got this, that told us what we divided our interest rate by 2. We got 0.037. So we now have 7.4. Example 5. Barbara invests $8,000 in an account which pays compound interest of 6% per annum compounded monthly. How long would it take in years and months for her investment to double in value? So if she invests $8,000, we want her investment to double. That means we want the final amount to be $16,000. The interest rate is 6%, but it's compounded monthly, so we need to divide that by 12, which is 0.005. And in this case, we are looking for N. So when we substitute in, we have 16,000 equals 8,000 times 1.005 to the N. So again, we'll start by dividing everything by 8,000. We now have this. Well, now we need to use logarithms to get to that exponent. So we could take the log of both sides. This time I'm going to do something different. I'm just going to change this to log form. So if I change this to log form, it is log of 1.005 of 2 equals n. So you can punch this in and you will get 139. Now we need to remember what units we are working in. This would be in months. So we need to find how many years that would be. So divide it by 12 and it would be 11 years and 7 months. Okay, last example here, borrowing money. When an amount of money is borrowed, interest is charged for the use of that money for a certain fixed period of time. If the loan is paid off in one payment at the end of the loan period, then the compound interest formula can be used. Andrea borrows $7,500 from her parents to buy a new car. Her parents charge her interest at a rate of 4% per annum compounded quarterly. When she pays off the loan, she has to pay $785 in interest. What was the length of the loan? So these questions are really very similar. The final amount, well, the final amount she owes is the amount she took out plus the $785. So in total, she now owes $8,285. The principal is the initial amount she took out, so $7,500. The interest rate, nope, sorry, that's not what we're looking for. The interest rate is 4%. So it's 0.04 divided by, it's compounded quarterly, so that means divide by 4. So our I in our equation is going to be 0.01. and n is what we're looking for. So now we go to our equation. We're going to start by dividing both sides by 7,500. So this equals 1.01 to the n. So again, I have two choices. I could take the log of both sides, or I could change form. Either way, here I'll take the log of both sides. So when I take the log of both sides, I have the log of, you could change this to a decimal here if you wanted, equals n times the log of 1.01. A bit more room. So now if I'm going to divide by log of 1.01, I do get that n is equal to 10. So that was 10 quarters. So how many years is that? Well, there's 4 quarters in a year. So this is 2.5 years.